In this lesson you learn more about solid figures, and more importantly you learn what a net is. Now a net is a two-dimensional pattern that you can fold to form a three-dimensional figure. Now let's make this come alive so you can better understand what this definition means. On your screen you see a three-dimensional figure, a cylinder that's there, and here you see a pattern. Now what I'm going to do is I'm going to fold that pattern and you'll see what happens. The pattern folds and it forms a cylinder. Let me flatten it again. When you flatten a three-dimensional figure, it reveals a two-dimensional pattern. So this now makes sense. A net is a two-dimensional pattern, this pattern here, that you can use to form a three-dimensional figure. Let's fold it again. While this cylinder is not of the same size as this, we can adjust the size or the height or length to make it equal in length to this, but we use this to illustrate the concept of a net. Now, why use a net? Well, packagers, people who make boxes or containers, for example, the label you see on your soda bottle, or the label you see on a can of milk, or the labels you see on packages, they are all nets. And packagers use nets to design the different types of fancy boxes that contain different types of food. So this gives you an idea of why you should understand what a net is. Now if you want to calculate the surface area of this cylinder here, you can use a net. For example, if this were a can of milk, for example, it would have a label wrapped around it. Now that label, when you unfold the label, when you flatten it, it will be in this form, and the designer would write on the label different items that is contained in the cylinder. Let's say if it's tomato soup, you will find the list of nutrition facts written here and so on, and an image of the contents like a bowl of soup and so on. So you will have the base length of the rectangle is the circumference of the can. The height of the rectangle, or the length in this case, is about the height of the can. So when you cut up a cylinder, you get a rectangle, this area here, and two circles. You use a net of a cylinder to find its surface area here. Since you can calculate the area of this rectangle, and you can calculate the area of this circle here, all you have to do is add the areas of the two circles to the rectangle, and you get the surface area of the cylinder. More of that in another.